scientists have discovered a new energy source that can be more beneficial than the ones we currently have. Hello and welcome back to CNN Daily News Report. I'm Tristan and today I have an interesting topic on new energy sources, being wave energy and ultracapacitor.
This being the ultracapacitor, a battery comprised of electrochemical cells consists of two electrodes separated by some distance. The space between them being filled with an electrolyte, a compound that converts ions when dissolved in certain solvents like battery acid.
Ultracapacitor works. Ultracapacitors hold a promise for similar job on the electric grid. Today, transmission lines operate below full capacity, often somewhere above 90%, in order to leave a buffer power for surges. Banks of ultracapacitors could be set up to absorb power surges, enabling transmission lines to run closer to 100%. It might not seem like much, especially considering it would take warehouse-sized banks for ultracaps to do the job, but installing the ultracapacitors to handle the size peaks would actually be much cheaper than adding even 5% more capacity with new transmission lines. Another energy source is wave farms. But what is wave power? Wave power is the renewable energy derived from ocean waves. It's kinetic energy of waves interacting with water and creating waves, said Peter Asmus, a senior analyst at Titan Research. Wave energy is already being used across the world. Millions of dollars have been used in order to the world's first wave farm, which opened near Porto, Portugal, 5 years ago. Wave farms employ massive buoys to turn the motion of waves into power. A major benefit to wave energy is that it's free and constant. In particular, it's easier to forecast wave energy output because waves are driven by wind but don't vary as rapidly. The energy from waves is more predictable from that of wind or solar, which means that it's easier to integrate into the power grid. Wave energy is different from tidal energy because wave energy is derived by wind. But where in the world can wave power be used? The best wave energy environments are along western coastlines because that's the largest, most consistent winds. Wave power hotspots are California, Oregon, Washington, and Alaska. Wave energy leaders include the United Kingdom, Portugal, Australia, and New Zealand.
How does wave power work? From the website Smart Planet, I quote, "Most of the energy comes from the rising and falling water level and requires exposure to the waves," Jacobson said. "There might never be a dominant technology for harnessing this power," he said, "because of the differences in potential wave energy sites throughout the world."
After talking about these new unusual energy sources, let's go back and talk about the old-fashioned way of getting energy, coal. What is coal and where does it come from? Well, coal forms from organic material that decays and experiences pressure and heat for millions of years. Since they take so long to form, fossil fuels like coal and oil are non-renewable. The process to generate energy from coal involves mining the coal, transporting, cleaning, and burning it. Water heated by burning coal converts into steam and generates electricity. Each stage of this process generates pollution. However, plans to reduce its pollution output may improve coal's standing as an energy resource. Benefits of coal energy. The U.S. contains 1/4 of the world's coal reservoirs, which could provide more energy potential than all of the known recoverable reserves of oil. More than half of the nation's energy comes from coal, according to the U.S. Department of Energy. This domestic energy source reduces the U.S.'s reliance on foreign fuel sources and provides jobs to Americans. How are they trying to improve coal energy? The U.S. Department of Energy and members of the private sector are developing cleaner processes for coal energy production. Their goal is to reduce or eliminate air and water pollution in newly designed power plants. In addition, the Department of Energy is working to recapture greenhouse gases produced from converting coal into electricity. More efficient energy extraction processes may also double the energy produced from coal over the next 2 decades. Improved coal energy production will lead to increased employment opportunities for Americans.
Another one of these resources is geothermal energy. Geothermal energy is the heat from the earth. It is clean and sustainable. Resources of geothermal energy range from the shallow ground to hot water and hot rock found a few miles beneath the Earth's surface, and down even deeper to the extremely high temperatures of molten rock called magma.
How do they work? Geothermal heat pumps can tap into this resource to heat and cool buildings. A geothermal heat pump system consists of a heat pump, an air delivery system, and a heat exchanger, a system of pipes buried in the shallow ground near the building. In the winter, the heat pump removes heat from the heat exchanger and pumps it into the indoor air delivery system. In the summer, this process is reversed and the heat pump moves heat from the indoor air into the heat exchanger. The heat removed from the indoor air during the summer can also be used to provide a free source of hot water. You can find geothermal pumps in the United States. Most geothermal reservoirs of hot water are located in western states, Alaska and Hawaii. The electricity produced by geothermal power operations is sold to local power grids, providing clean energy to fuel the growth of some of the world's most rapidly expanding economies. But geothermal energy. Geothermal energy has the potential to play a significant role in moving the United States and other regions of the world toward cleaner, more sustainable energy systems. It is one of the few renewable energy technologies that, like fossil fuels, can supply continuous baseload power. Costs for electricity from geothermal facilities are also declining. Some geothermal facilities have at least 50% reduction in the price of electricity since 1980. There is also a bright future for the direct use of geothermal resources as a heating source for homes, businesses, and any location. However, in order to tap the full potential of geothermal energy, two emerging technologies require further development: enhanced geothermal systems, or EGS, and co-production of geothermal energy in oil and gas wells.
This segment, let's talk about one more thing. As you can see from this graph, coal makes up more than half of the chart, but the problem is that coal is not a renewable resource. So what happens when its supply starts to run out? Well, that is where our newly discovered energy sources come into play. Wave farms are very stable and are able to provide ample power to us. Also, waves continue on and on, so they are everlasting. This allows this new energy source to be reliable enough that we know that it can last for a long time. Also, with the new ultracapacitor, it already is great, but in a few years it will be modified with new technologies and become even better than it already is. The new energy sources have a chance to surpass the energy sources that we use today. Thanks for joining us. See you next week.